What if we trashed Earth's orbit with space junk? From the moment humankind first breached Earth's atmosphere, sending satellites, rockets, and astronauts into orbit, our fascination with the final frontier has been a defining part of our identity. The dreams of exploration, the satellite networks powering our communications, and the extraordinary scientific instruments gazing deep into the universe all share one thing in common: the fragile highway of near-Earth orbit. But with great ambition comes great responsibility. And for decades, Earth's orbit has quietly filled with the debris of our aspirations. Spent rocket stages, shattered fragments from collisions, inactive satellites, and the tiniest flecks from paint chips to metal bolts drifting far above our heads. Imagine a scenario where, unchecked and unplanned, this trend accelerates, where we trash Earth's orbit with so much space junk that it becomes an unmanageable, hazardous minefield. What would this mean for our life on Earth, for satellites, for space exploration, and for the very future of science and civilization? Let's explore what would happen if Earth's orbit became a literal trash trap, a situation scientists have warned about for decades, famously known as the Kessler syndrome. To fully understand what's at stake, we need to start with a clear picture of just what space junk is, how it currently impacts us, and what might happen as the consequences spiral out of control. Space junk, space debris, orbital debris, they're all terms for the same thing: human-made objects in space that no longer serve a useful purpose. Ranging from entire dead satellites to nuts, bolts, flecks of paint, and even wrenches accidentally dropped during spacewalks, these fragments orbit the planet at astonishing speeds, sometimes faster than a speeding bullet. Currently, agencies like NASA and the European Space Agency estimate that millions of pieces of space debris orbit Earth. Though we only actively track some tens of thousands of them, mostly those larger than 10 centimeters. The problem is, even the tiniest pieces can cause devastating damage due to their immense velocity. What if, over the coming years, we kept sending more satellites, conducted more launches, and allowed degradation or destruction of objects in orbit to outpace our management activities? Every collision creates more fragments. When a derelict satellite shatters on impact with another piece of debris, thousands of new shards are born, each multiplying the problem, and each one capable of inflicting lethal damage on the next object it encounters. This chain reaction is at the heart of the Kessler syndrome, a nightmare scenario in which the density of debris becomes so high that each collision leads to an exponentially growing cascade of more collisions, more debris. In this scenario, the space around Earth, especially the crucial altitude bands of low Earth orbit, LEO, where most of our crucial satellites and the International Space Station reside, becomes a shooting gallery. The implications are massive. First, consider how heavily we rely on space-based technology. While we don't often see it firsthand, our daily lives are underpinned by a vast array of satellite services. Weather prediction, so that storms, hurricanes, and other natural disasters can be forecasted and lives saved. GPS and navigation, steering airplanes, ships, logistics, personal navigation for drivers and hikers alike. Communications, binding the world together with TV broadcasts, phone calls, and internet connectivity, especially in regions otherwise underserved. Earth observation for agriculture, climate research, and disaster management. Scientific satellites unlocking the secrets of our planet's climate, geology, and the greater cosmos. Imagine waking up in a world in which these services are disrupted or lost entirely. The morning news can't deliver weather forecasts. Aircraft have to rely solely on ground-based navigation aids, reverting to slower and more error-prone methods for crossing oceans. Shipping lanes become more hazardous, and the global supply chain wobbles on outdated technology. Emergency services lose their ability to coordinate instantaneously over large areas. The financial sector, which depends on precisely timed signals from GPS satellites, feels the shock. Hospitals can't access telemedicine or vital data from space-based resources. Even a simple phone call home or a message sent across the world becomes less reliable. As the orbital environment grows more hostile, Launches to place new satellites become risky. Rockets would have to dodge the gauntlet of space debris, each piece a potential bullet ready to pierce fuel tanks or cripple delicate electronics. Even the International Space Station, which already must periodically maneuver to avoid debris, could become so threatened that losing it is unavoidable. Every mission to repair, update, or expand our presence in orbit faces astronomical insurance costs, or worse, becomes impossible due to safety concerns. The tragedy doesn't end with practical disruptions. Our pursuit of knowledge would suffer too. Thousands of telescopes, Earth observation satellites, and climate monitoring devices orbit our planet, providing insights into the universe, weather, natural disasters, and humanity's impact on Earth. As orbital lanes become littered with junk, the risk of catastrophic loss for these scientific instruments increases. New launches for cutting-edge exploration, missions to other planets, the next Hubble or James Webb telescope, require safe transit through these debris-laden bands, further closing a vital window on discovery. Perhaps nowhere is the impact more profound than on humanity's aspirations to be a spacefaring species. With orbit trashed, the very first step toward missions to Mars, to the Moon, to the outer planets, indeed, even simply escaping the grip of Earth's gravity, becomes an ordeal of hazard and uncertainty. In the worst-case scenario, if the debris cascade is left to run its course, we could reach a point where launching anything into space is effectively impossible for generations. The risk is simply too high, the sea of flying hazards too dense. Day to day, the dangers aren't just theoretical. The International Space Station and satellites routinely perform collision avoidance maneuvers, burning precious fuel to change their orbits to avoid tracked debris. Hundreds of times a year, these objects come close enough to warrant red alerts. Astronauts shelter in escape capsules when the danger is at its peak. In 2009, the collision between an inactive Russian satellite, Cosmos 2251, and an operational Iridium communications satellite produced thousands of pieces of debris. By many still orbiting Earth, and endangering everything in their path. If this trend continues or accelerates, the number of close approaches, known as conjunctions, would climb into the thousands or millions annually. Eventually, keeping anything safe in orbit would become impossible. Even lower orbits, which are naturally self-cleaning as atmospheric drag gradually pulls debris down to Earth, would become hazardous as new junk replaces the old faster than drag can remove it. Let's dig deeper into the full consequences for the planet and civilization over the short and long term, recognizing that a trashed orbit isn't just a technical or scientific annoyance, but a profound societal risk. First, the economic impact. The space industry today is worth hundreds of billions of dollars, underpinning vast sectors of the global economy. A full-blown debris crisis would disrupt the launch sector, slow or halt satellite manufacturing, and cause insurance costs for space assets to skyrocket. Many companies relying on satellite imagery, communications, and positioning would be forced to adapt or fail. Jobs would be lost, research stymied, and the knock-on effects, slower communications, unreliable logistics, and less accurate navigation would ripple through all industries. Second, international security. Both military and civilian satellites share orbits. Weather data vital for disaster response and military operations would be threatened. GPS, critical for modern weapon systems and troop movements, would become unreliable or unavailable. The loss of situational awareness in space would blind nations to threats, complicate arms control and early warning systems, and heighten international tensions. The struggle to clean up or mitigate debris, or to blame one another for its accumulation, could even become a source of political conflict. Third, the socio-political and psychological toll on humanity. The dreams of future generations to explore space, to set foot on Mars or the Moon, to venture beyond even our solar system, would dim. Science fiction, once a source of inspiration, would become a bitter reminder of what could have been. Students inspired to become scientists and engineers might find the doors to their dreams closed, at least in the fields of space exploration. But perhaps the most chilling effect is the environmental feedback. A trashed orbit, full of debris, eventually rains that broken material back onto Earth. Though most small fragments burn up in the atmosphere, larger objects sometimes survive to reach the surface. In a world where satellites and debris regularly decay and fall back, the risk, however small, of harming people or property increases. Already, we've seen debris crash land in unpopulated areas. Multiply the number, and the risk to people, animals, and infrastructure grows. The atmospheric re-entry of toxic materials, such as hydrazine fuel or radioactive elements from research satellites, could increase pollution and risk. In the longer term, a world that can no longer reach space faces a kind of technological lock-in, stalling innovation at one of humanity's greatest frontiers. The tools to mitigate or adapt to other problems, climate change, natural disaster, large-scale communications outages, navigation errors, are hampered by the loss of space-derived data. We might even lose our vigilance, with each passing year making the prospect of cleaning up the orbital environment more remote. The cost, both in treasure and time, rises as the dangers multiply. All of this seems dire, but humans are nothing if not inventive. There are solutions, difficult, expensive, and politically complex, but not impossible. The current spectrum of proposed actions falls into several broad categories. 1. Prevention, limiting the creation of new debris by improving rocket staging, requiring safe post-mission disposal of satellites, and enforcing end-of-life deorbiting of inert objects. 2. Active mitigation, developing technologies to remove existing debris, such as nets, harpoons, robotic arms, or balloons, and pushing for international treaties to fund and regulate cleanup. 3. Observation, enhancing the tracking of even the smallest pieces of debris with radar, optics, and new sensor networks so that spacecraft can better avoid collisions. 4. Innovation, designing future satellites and spacecraft to be more robust to impacts or capable of maneuvering themselves away from danger. But these actions require unprecedented levels of international cooperation, sustained funding, and a global recognition that space is a shared resource, not a dumping ground. If national interests, commercial competition, or neglect win out, the scenario we've explored could begin to unfold piece by piece, year by year, launch by launch. Ultimately, trashing Earth's orbit with space junk is more than a technical story. It's a lesson in stewardship, an encapsulation of humanity's relationship with our environment extending beyond the planet itself. Where once we polluted rivers, skies, and land until crises forced us to act, now we face the same dilemma in the dark, silent void above our heads. The stakes are larger, not just for our livelihoods and daily comforts, but for humanity's role as explorers, scientists, and caretakers of the future. If the problem is left unaddressed, we accept a world diminished, a civilization forced to look inward, hobbled by our inability to resolve the byproducts of our dreams. If instead we confront it, mobilize our science, our innovation, our international goodwill, we preserve not just the practical benefits of space for ourselves, but the hope that future generations will look up, see stars, and know they too can reach them. So ask yourself, as we continue to launch, to network, to explore, what responsibilities do we share? To each other, to future generations, and to the delicate boundary between Earth and space? The story of space junk is not just one of danger, but of opportunity. To learn, to adapt, and to reaffirm that humanity's gaze outward must always be matched with care for what, and who, we leave behind. Today, the fate of orbit is in our hands. The next chapters depend on the choices we make together. Thanks for sticking with us until the end of the video. What do you think would really happen if this became reality? How would the world change? Share your thoughts or your own what-if theories in the comments below. Who knows, your idea might inspire our next video. If you found this interesting, don't forget to like, share, and subscribe to keep exploring the wildest possibilities with us. See you in the next unexpected what-if adventure.